Welcome to part one of our Laboratory Risk Management webinar presented by the Royal Australian Chemical Institute, the Professional Association for Chemists in Australia. I'm Matthew Wilkinson, Chair of the RACI New South Wales Industrial Chemistry Group. The topic of this two-part webinar series is laboratory risk management. As we heard in part one, risk management is an extremely important part of running any sort of organisation, and one that's been brought into focus through the emergence of the COVID pandemic. The laboratory environment is a very common environment in which a chemistry graduate might find employment, and one that presents sometimes quite unique risks. Tonight, we'll continue our discussion of risks in the laboratory environment and talk to some professionals in different lab environments and see the sorts of risks that are presented and how they are being managed. Before we start this evening's panel session, we'd like to acknowledge the traditional custodians of the land on which we are meeting all around Australia. We recognise the elders, past, present and emerging, and also recognise their contributions as Australians' first scientists and engineers, building a healthy and safe community, what they've done, and what we can still learn from their ways. I would also like to welcome Nigel Davidson back to our webinar tonight. Nigel is Senior Risk Management Consultant at Victual Industries, and he gave us an excellent framework of risk and identification and management in the first part of our webinar 2 weeks ago. A copy of that presentation is available on the RACI YouTube channel for those who missed it, and I would really recommend this as a great resource for anyone interested in managing risks. Nigel will be available later on tonight to participate in our discussion and to answer any questions you might have. I would also like to welcome our three excellent speakers for tonight to take us through the second part of our webinar. Please welcome Dr. Geoffrey Shee, School of Chemical and Biomolecular Engineering, University of Sydney, Katherine Barbeler, Head Science Teacher at Gosford High School, and David Springer, Commercial Manager, Envirolab Services. I've asked each speaker to talk about their role and their particular organisation, the risks and challenges faced with COVID and other risks, and how these challenges are overcome. So firstly, I'd like to hand over to Dr. Geoffrey Shee from the School of Chemical and Biomolecular Engineering, University of Sydney. So I'll hand over to you, Geoffrey.
Thank you, Matt. Thank you everyone for attending. And I'm Geoffrey Shee. I got my Bachelor in Engineering and a PhD in Chemical Engineering. I'm a fellow member of ICI Chartered Chemist, and also I'm Chartered Engineer, member of ICME. I'm also Standard Australia Safety in Laboratory Committee member, the member responsible for AS/NZS 2243 for the standard update, adding, review, etc. I work for Sydney University since '96. That's almost quarter century now. And I'm technical manager responsible for all non-academic issues in the school and safety officer building chair. Sydney University is almost 60,000 students and around 8,000 staff. So it's a very big organization with a budget around 2.7 billion a year. So a very complex structure from highest level is Senate and to the faculty, which I am in the Faculty of Engineering, and then down to school level. So typically faculty is, university is responsible for developing various work health safety policy, and school faculty responsible for implement and action. I'm second on the school level, so school safety committee, department safety officer, so we are responsible for day-to-day operation in the individual schools, research laboratory, teaching laboratory. What do I do in the school? Next page, please. So school have safety committee will meet regularly, responsible for school policy, safety rule, implementation, and advice and support to all our students. We do safety induction for every newcomer, student, visitor, contractor, staff. And we do the regular inspection in laboratories. We're also responsible for incident investigation, review, reporting through our online riskware platform. For any new research project, there is a project-based risk assessment requirement for any happening in the building. So we are using a so-called green permit system to safe check all activity happening in laboratories. Student and staff must go through the risk assessment, get a permit to go ahead before they are allowed to work in the laboratory. We are also responsible for hazardous substance management, procurement, handling, use, safe store, and waste disposal in this particular school. We also have the ECO, Emergency Control Organization, operating in the building, which responds for emergency management. We have once a year evacuation drill. We have once a year lockdown drill to familiar with all our student staff in the building. So why project-based risk assessment? Because universities do various research, some of them very unique, and some of the risk level is unique. Our academic always try to push the envelope to try to compete new for other talent across the world. When you go to that type of area, some of the risk is unknown. So all research project is unique. We have to, based on that type of research project, do a proper risk assessment. Also, individual research assessment help find the gap and a learning curve for the student. In the end, we can help to recommend what specific training needed, what is the gap there, and what we know unknown. Last not least, project-based risk assessment also a good documentation and the protection of a potential negligence case. In the end, all the staff have duty of care for the student under their care. We do need that type of document and the protection just in case. And the work health safety law has all sorts of requirements. Next. Let's do a quick case study for risk-based assessment. A microbe assessed antioxidant extraction from orange peel. What type of material involved? Pure water, orange peel, very simple and non-hazardous. The operation temperature is moderate, 150 degrees, but still can go wrong. See, that's the one has the incident involved. That's the high pressure vessel can withstand 100 bar. Under normal operation condition, that's why be very safe, no risk at all. But that case in our school and in my lab, it happened. It's overpressurized and exploded. And what happened? Because the water used, the orange peel used, the pressure design limit, the temperature, all on good course will be okay. But that has the limit. For example, that vessel is 100 milliliters. The recommended operation, the water you use, the sample you use is not over 20%. For example, 20 milliliter in a 100 milliliter vessel. It's perfectly safe. The temperature 150 degrees, pressure will be well within the limit of 100 bar. But that particular student use that one, ignore this limit. You put too much water there. Imagine for 100 milliliter vessel, you put 98 milliliter of water there. When heat it up, will expand with overpressure. So the consequence is incident. So that type of case study we use for every student to learn from it. Next, please. Particular challenge in our chemical laboratories. As a chemical engineering laboratory, we routinely handle hazardous substance. We routinely handle extreme operating conditions. For example, high pressure up to 300 bars. High temperature, we run up to 1500 degrees. We also run a complex pilot plant operation. For example, one of our research does ammonia nitrate synthesis from ammonia feedstock. So all the way from ammonia oxidation, nitric acid, then combine form ammonia nitrate, pilot scale. So we're talking about the kilogram of operation. That type of size, that type of extreme temperature, pressure, if it goes wrong, with very big consequence for. So project risk assessment will scrutinize every step, what we know, what we unknown, what we can do to mitigate the risk. For that type of scale operation, typically will involve third-party professional risk specialists go through the HAZOP or CHAZOP to make sure all the risk is addressed. Next. Other challenge, except that the hazardous material we're handling, the condition, the scale, is people or human being in the school. Everyone at university have new students every year. Senior university is 70,000 student scales, and our school is around 500. We got around 80 postgraduate students in the research. Our postgraduate student, by the way, that one is the pilot scale for the ammonia nitrate operation. So feedstock ammonia, around 2 kilogram size, go through the oxidation, catalytic oxidation at high temperature and pressure, generate the nitric oxide, then convert to nitric acid, reaction with ammonia again, make ammonia nitrate, which is collaborated with the world's largest explosive, Yara. Previously, that operation is Orica. So we just mentioned the challenge for the extreme condition, hazardous material. Now let's mention the human beings. It's even challenger. The main point for here is our postgraduate. Senior university have very big percentage of the overseas student. That's overseas student come from very different background, from Southeast Asia, China, South America, Middle East. Their safety training, their understanding, their culture is very different. So how to bring them all to same standard? It's a big challenge for us, and we have to do every year. Next. Just to give example for the different background student, for emergency call number. And here in Australia, we know 000, but this number very, very, very differently across the world. Imagine you're from India. Obviously, you are thinking not 000, not that emergency number. That type of number in their memory is deep. In case of emergency, their reaction may be called 000 in Australia, but in my country there, original country, not. So that's things we have to repeat and repeat. That's the student. You are in Australia, you are working in the Australia laboratory, you have to follow Australia laboratory safety rule. COVID for us, it's the good or the bad. The good thing is we got less incident happen in the laboratory on the campus because we have no student in the laboratory, no student on the campus. Most undergraduate course is delivered online for Zoom and others. The challenge is we almost over the night we are asked to develop an online course to be delivered almost overnight. So everyone is right to the time to develop the course for online. We also develop some online training for laboratory experiment session. We still need to review how good is it, and the student feedback is yet to summarize. I think some of the shift because COVID is temporary, but some can be permanent. They will have long-time consequences. For example, job loss probably is inevitable, and some of them probably long-term. Some of them probably never recovered. But the online course also have some good things. Myself actually take some long online course, like the MOOC. I feel it's very, very useful, low cost, and easy to handle because it's on need, on demand. You can choose whenever you need, when you suit you, and the cost is negligible compared to normal university course. A subject cost is $4,000 or $5,000, but that type of online course delivered by very distinguished university scholar, cost is really fraction. So I feel that type of online course will be there, and more will be there. So we will feel the competition all over the world. That's it for me. Thank you for everyone.
Thank you very much, Jeffrey, for your presentation. I'd like to now hand over to Kathy Barbeler, Head Teacher of Science at Gosford High School. Thank you, Kathy.
Thank you. Good evening, everybody. As I've been introduced, I am Head Teacher Science at Gosford High School. So I'm representing a Department of Education school, co-educational. We're a regional selective high school. Listening to Jeffrey speak, I realised that we have some things in common. So in terms, my main risk is actually the students. And like he has students coming from our schools into his tertiary sector, probably my biggest risk are our younger students who have actually never set foot inside a laboratory. So our Year 7 students haven't been into a lab. Many come to us that have never even struck a match. So even lighting their Bunsen burner is a bit of a challenge. My greatest challenge is probably the teachers do the risk assessments on behalf of the students. So what's just displayed to you now is, this would be very common in most schools. It's an online risk assessment tool. We all pay annual subscriptions. I can only comment from a departmental view. So annually we pay, I think it's $250. That gives us access to this tool. Every single experiment that a teacher does would be ran through this tool. And this is how teachers are actually placing their order for the laboratory assistant. And then in the background, some schools, I do this, I do it because I've got extension science students. We pay for the student risk assessment. And as the students progress from Year 7 to Year 12, so in the school I'm currently in about Year 10, I'm starting to expect students to be doing their own risk assessments on some of their experiments. Year 11 and Year 12, it's basically compulsory. If not every experiment, we try and get them to do at least a few a term. So hopefully we're getting good skills, Jeffrey, that they're coming to you, and risk assessment is not completely foreign to them. Then in the background, if I can get the next slide maybe. Yeah, in the background, this is what the order looks like when it gets to our lab assistants. So I guess many labs wouldn't worry about ordering, risk assessing things like food colouring and detergent. So I've deliberately displayed one here that is, probably would be evaluated as very low risk, but this is just to show you that we run everything through that we're using with our students. So even if it's perceived as food, just normal food, that would be ran through, which, you know, and when the students are doing their own experiments, we say to them, you've got to put everything through. If you're doing an experiment with it, it's you're treating it as a chemical, see what the potential risks are. So that's what the lab assistants get. And if I can get the next slide. So here, after the teachers have placed the order and it's been ran through the online tool, teachers then evaluate the risk, whether it's low, medium, high, or extreme. We wouldn't be doing it in school. And in reality, if the lab assistant saw something above medium risk, it comes to me as the head teacher. And if it was a chemistry-based one, for example, so all teachers in secondary schools have got what we call codes. So somebody that is teaching chemistry has been assessed by the Department of Education to actually have the qualifications to teach chemistry. If somebody was trying to do a chemistry experiment and the risk went above medium, it probably wouldn't happen, or we'd get a colleague who actually has got that chemistry qualification to do the experiment with the students. So low and medium is where we sort of target. All of the chemicals we use in schools have got chemical safety codes. So there's different colours, which is how the lab assistants work. If anything there's certain chemicals. So for example, I was using one today, hydrogen peroxide. I was with year 12 chemistry students. They're allowed to personally use 3%. The experiment that we were doing a version of elephant's toothpaste for a reaction rate and use of catalysts. They obviously got results using the 3%, but it wasn't the way it should be. So when I went to the 6%, they weren't allowed to use the 6%. So that just gives you an example. The concentrated sulfuric acid is another one that our senior chemistry students often need to use in the organic lab. For example, making esters. That's teacher use only. So in a way, risks in schools rely a lot on the qualification of the teacher. And also the work of the lab assistant, and that's probably one of the biggest difficulties in schools actually, because our lab assistants, who are integral to the science faculty, may not have formal training in science. So many, and I must stress I'm only speaking on behalf of public schools, many are what we call SAS staff, school administration support staff. They're actually recruited on the same level as what somebody working in the office may be. And the lab assistant may start off 1 day in the lab, 2 days in the lab. The training that comes really is from the science teachers themselves. So, and in the past, there have been a few online courses, but not many lab assistants would have formal training. It's sort of on the job. So I can get the next slide. With the advent of COVID, like Jeffrey, basically overnight we went from having kids at school to all of a sudden, okay, you're delivering everything online. There was no planning and no transition stage whatsoever. So most of our courses, yes, we scrambled and everything went onto Google Classroom. Again, we're dealing with 12-year-old kids up to 17-year-old kids with varying degrees of technology and varying degrees of support at home. And like all of us, we're probably all working parents. We know it wasn't always easy to have kids at home trying to learn with teachers who were also learning at the same time. So yes, we went online. How successful that was, I think time will tell. Kudos to the kids and their parents. I think from schools and families working together, we all got through it. And I think amazing work has been done. In terms of teaching chemistry, experiments that they should have been doing, we were doing and we were filming. They're the experiments that students don't recall as easily, is what is my impression when I looked at their trial HSC. The experiments that they had watched their teachers doing films of weren't quite as good as them doing it themselves. Then when they eventually came back, there was a little bit of a grey area about whether they were allowed to do experiments or not. This is because of COVID. We weren't really very well set up. So, you know, we all of a sudden had students back and we had to have extra COVID measures. So this is unique maybe to my school. I think most public schools, students don't have their own safety glasses, so that's probably different to university. We have safety glasses for them and they always wear them for experiments, but therein becomes a contamination issue because, you know, in period one set of students are wearing it, period two another. We thought long and hard, what do we do here? Do we clean it for them? In the end, what we've done at our school is teach the students that they're responsible for their own hygiene. So when they use the safety glasses, they get them out of the disinfectant solution and they wipe them clean, they wear them and they put them back. And then the next students would clean their own safety glasses. That's been the same with cleaning of their desks and their chairs. We've tried to get each student to be responsible for their own area. We've provided sanitizer, teachers prompt and remind, and that's probably basically it. In terms of touching of the equipment, we don't, we've again adopted the strategy that if you use the equipment, you clean it and you put it back clean, but then wash your hands very well afterwards. So that's one of the main things. In terms of major risks in schools, we probably don't have, I mean, there have been instances where there's bad accidents, but most of the accidents are like topical burns or students spilling chemicals on their hands, and it's their hands are washed. Their burns are treated with normal first aid. As diligent as we be, I think our major risk is we're dealing with very inexperienced students and very young students who are a combination of excited, nervous, all the rest of it when they're conducting their experiments. And if I can get the next one, I think that's it. Yeah, yep, that's it. So thank you. In terms of schools, our greatest risk are the students.
Thank you, Katherine. Yeah. Thanks for the presentation. Just like to hand over to David Springer, Commercial Manager at Envirolab Services. Thank you, David.
Thank you, Matthew. And good to hear, Kathy, that they've got the school's got the risk assessment. I don't think we had that in 1980 at Asquith Boys High when we were juggling mercury. I tend not to remember. Okay. Yeah. So tonight I'm going to take things in sort of a different direction because we you know, a lot of the risk assessment is all the same. So I'm going to give you a bit of a case study tonight. So we'll go to the next slide. So just a little bit about Envirolab. So we are a private environmental laboratory with labs around the country. We've got about 200 staff. Now we mainly test things like soil, water, air samples, and we are a high throughput lab. So we're doing about 30,000 samples a month for analysis. So as a commercial lab, our aim is to get the samples in, get them tested, and get the results back to the client as quickly but as safely as we can. Thanks. So our risks, pretty much the same as these would be coming up in pretty much all labs. Same as schools or commercial labs. So the chemicals, the acids we use, any of the byproducts, the fumes from analysis. You know, we do a lot of aqua regia, metal digestion, so a lot of nitric fumes. All of our equipment and instruments we use. And then we do have a large staff as well. So we've got to make sure we have ergonomics and all the fatigue management all looked after, and the usual manual handling. But this little case study I'm going to do tonight is all about our samples. So the problem with an environmental lab is that we just get the samples coming in. We often don't know what they are. So I'll give you a little look at this. So we received some samples in from a customer from a very well-known site in Sydney, a very contaminated site. And the customer did the perfect thing. They were absolutely correct. They wrote on the chain of custody that the samples may contain high levels of OC pesticides or SVOC, semi-volatile organic compounds. So they did the right thing. They flagged that to us. But unfortunately, our guys here in the lab booked it in as just a normal old soil sample. So we didn't make a note that it was actually a white powder. So it wasn't a soil, it was actually a white powder that should have set alarm bells ringing. And this was going down to our asbestos lab. The customer wanted asbestos on it. So the guys in our lab had a look at it, thought, oh yeah, it's a powder, but you know, we can still test it, it should be fine. We'll put it in the oven at the end of the shift at 5 o'clock and let it dry overnight. So at 5 o'clock, they loaded about 1 kilogram of this white crystalline substance into a laboratory oven. So next slide, Matthew. So next morning, first guy into the asbestos lab noticed a terrible smell in there. He just thought it was a normal soil sample, just a smelly sample. So he put on a mask, turned the fans on, kept on doing his work. A couple of hours later, he went outside and he noticed that his clothes were smelling. So he informed management. That's when we got involved, and we all toddled off down the road to the asbestos lab, and we had a look around and we had a bit of a smell. We couldn't work out what it was. There was nothing unusual around. So we, opened up all the doors to flush the smell out. Finally, that photo down the bottom, we worked out what the problem was, and we couldn't work it out because there was nothing there. So 1 kilogram of white crystals disappeared into that dirty residue down the bottom, and that's when we finally found it. So on day 3, the smell was worse after we locked it up overnight. We had a really quick meeting of our management and our safety team, safety committee, and decided to move. We have about four to five people working in that lab. So we shifted all those analysts and all of their microscopes out of that lab. We decided to turn the air conditioning on to a high temperature to try and flush out that smell, and we got some fans going to push the hot air out. So this time we still didn't know what the story was. But you'll see down there, we eventually did some testing on day 3 and worked out that it was mainly tetrachlorobenzene is what we volatilized a kilo of. And so tetrachlorobenzene is basically used in the production of fungicides and Agent Orange and all those other good things. So that was now in our lab. So over the next 2 weeks, the managers all suited up and we washed everything. We had the carpets cleaned. We started doing our own testing, and we showed that the cleaning was working. The air testing results were going down. We had an all-staff meeting and presented an action plan to staff of what we were going to do. Over the next few days, we did several more deep cleans. We had a pretty new $10,000 oven, which we just had to throw out. We could not get it clean. And that was actually, the asbestos lab is also our storeroom for all our jars and bottles. So we actually had to dispose of thousands of brand new jars and bottles. We couldn't use them again for any samples. So we then hired some scaffolding. We did a full weekend cleaning with peroxide. And then we did a whole lot of more air samples. And what do you know, everything was still positive. Next slide. So we're now looking at day 13 up to day 33. We employed 2 occupational hygienists to give us some advice. Because our results weren't going down quick enough, they recommended actually removing all the soft furnishings. So all the chairs, the air conditioning ducts, all the pin boards, everything, curtains, everything was ripped out of the lab and disposed of. And then one of them suggested this hydroxyl machine, which I wasn't aware of what it does. You can have a quick read there of what it does. We're assuming that hydroxyl machine did work because, probably that hydroxyl machine in conjunction with all the cleaning we did is probably what worked. So we'll move on. Now heading up to day 40 now, and this is getting really serious. We then re-cleaned all the surfaces again. We had the tradesmen in to re-air condition everything. All new carpets laid. You'll see that picture of an air pump there. That's all the carpet ripped out. We did not only air monitoring, but we were doing virtually daily surface monitoring as well with swabs. And finally, the results were looking good enough for our occupational hygienist to issue us with a clearance certificate on the condition that we continue monitoring every few days for the next few months. So day 60, so 2 months later, our staff were able to move back into that laboratory. All up about $60,000 worth of just things that we threw out and analysis and hygienists. And unfortunately, insurance didn't cover anything of that. We had a little clause in our insurance policy that we didn't know about, which excluded contamination, which was very disappointing. So the next slide. So lessons of that. Look, it was a $60,000 lesson to us. It could have been so much worse. We were so lucky that this was done in one of our very small laboratories of 4 people. Our main lab here in Chatswood, has about 50 staff in here. That's where we did the bulk of our testing. Had it been in here, that would have been an absolute disaster to have all of our staff in our main lab out of action for 60 days. So all of this is now included in our inductions for new staff. We actually have a presentation very similar to this that all new staff must go through. And one of the most important things that came out of this was that every oven in all of our laboratories must be under ventilation 24 hours a day. This particular oven wasn't, and that was something we missed early on. So this, it was a very expensive lesson, but we are quite happy that this happened because it did teach us so many things. So that was my case study for that. I think I'll move on. Oh, there we go. So just look, that's my chicken leg there. I had to hire these big gas blowers, which had to heat up the labs. We had to get the labs heated up to 30 or 40 degrees. So we had these giant gas blowers, and obviously that's very dangerous. We had to have people down there monitoring these gas blowers constantly when they were on. We couldn't leave them alone. And I'd been to the gym one morning at 6 a.m. and I came in and thought I'd warm up in front of the gas blower. So the smell of my burnt leg hair is probably as bad as burnt pesticides. So we'll move on. Okay, so I thought I would just finish up in the last 5 minutes just with what we did as a commercial lab with COVID. So again, at Envirolab, we find that communication is very important. So just like the last example, we immediately formed a team to get an understanding of what was happening. And that team started to write procedures because we didn't have procedures for COVID. We had to make decisions, and importantly, we had to do risk assessments. And I'll show you later on, one of our biggest and our highest risks we felt were commercial couriers. We had to get the essential services letters written. We had to get the safety signs put up. We've got about 100 staff here in Chatswood. Obviously, most of them have to do the testing, so we could only get about 15 of them to work from home. But of course, that's not really common in a lab to have people work from home. So we had to go through the whole home risk assessment. We had to go out and buy fire extinguishers and chairs and everything for our HR and IT people who had to work from home, which is great. That's all done now. We couldn't get hand sanitizer. That was a real problem. In our Australian labs, obviously we have IPA for our testing. We just had to use IPA instead of hand sanitizer. That's all we had. And for our wiping down our computer keyboards and our telephones, we do a lot of methamphetamine testing. So we had to raid all our meth kits for alcohol swabs as well. Because again, we couldn't buy them. So something we learned out of that is we always need a little stockpile of these things just in case. Next one, Matt. So we also put another few rules in. Obviously, we took the government's advice. So anyone who was catching a train needed to wear a mask once the government advice came in. We cancelled, unfortunately we cancelled, we do a lot of uni and a lot of school work experience. We cancelled all of that. We couldn't take the risk of having, you know, uncontrolled people coming into the lab. Any necessary visitors, so any tradesmen or maintenance contractors, all had to scan in and wear a mask when they were here. We staggered the breaks. We had lots of cleaning, so even 3 times a day, you know, as I was going to the kitchen, I'd then wipe down the microwave and the toilet doors. And along with me doing it and about 3 other people doing it, I think we were cleaning things pretty much on the hour. We went to single-use tea towels. So I don't recommend to anyone washing 200 tea towels every night. It does get a bit draining doing that, but we did that to try and stop any, you know, communal use. And of course, all the Zoom meetings and whatnot. So next one. So our staff were actually really, really good. We were communicating all the time, and we made sure they all knew that as per the government advice, any sickness, they had to stay home. And this kind of taught us we could pretty much do a risk assessment in our head after the first 2 days. So some of the things, you know, these are all real examples. So someone's flatmate, their parents were positive, should he come to work? So fantastic that he rang up and he asked us that. We then ran through a number of questions. We then worked out that it was an acceptable risk to us for him to come to work. You'll see that bottom one, you know, woke up with a runny nose, took an antihistamine. So this person did have a history of hay fever. We questioned where they had been. They hadn't been anywhere. They'd only been at their own home. So we deemed that as an acceptable risk. So this was good. We were probably doing that, probably with 100 staff, probably any one day. I don't know, you could probably think 5 to 10% of staff are probably sick on any one day. So yes, by the end of the first week, we were pretty on the ball getting these quick risk assessments done. Okay. So we also had to do some little engineering things as well. So we had to come up with a, this was from our Melbourne lab, we had to do a little homemade sneeze guard, you'll see there in the middle, to try and separate some people. Next. We also decided that if we did have a contamination scare here, that we would do our own cleaning. So we actually formed a deep clean team. Now this deep clean team, we wrote a procedure, and we basically, that's pretty much a kit of what is in there. Very, very clear procedure of exactly what to do. You know, right down to the people on that team having a spare set of clothes at work, so that if something happened, they could change into those. So, you know, we had measuring cylinders in there so they could measure out exactly how much bleach to use and whatnot. We just figured the cleans. We just figured that, look, this is our business. We're chemists, we're all scientists. We know what is best, and we will do a better job at cleaning. So we basically set that procedure up based on the US Centres for Disease Control, because the Australian government was a little bit slow on the uptake. So here we were as a lab, and a lot of your businesses as well, you know, you wouldn't have had COVID procedures. Australian government didn't have COVID procedures either. So it took a good few weeks before the Australian government came up with their procedure. Luckily, that was pretty much the same as the CDC. We'll go next slide. So all the distancing rules, every room had to have a distancing rule. But we had to be a bit practical about it as well. So that's the sign on my little fishbowl office. I was only allowed from the square meters, I'm allowed 1.5 people. We just had to make a little practical rule down the bottom. Okay. So yes, couriers. So our Sydney lab gets about 200 jobs a day, the bulk of those coming from commercial couriers who are travelling all around Sydney. So we put rules in place. They were not allowed past the loading dock. All of the esky handles for samples had to be wiped down with alcohol wipes before our staff touch them with gloves. Once our stocks of alcohol wipes came in, we offered those to couriers as well, and they could take those away with them just to help, and prevented couriers from, you know, labs are a good place for couriers to use the toilet and whatnot. So we banned them totally from coming in. And we actually got very, very positive feedback from our customers on those really strict rules. So poor Melbourne, it was an absolute rush in Melbourne to do this. We had to get the essential services work permits out. These guys couldn't buy material. Spotlights in Melbourne had no material available. We had to ration the masks the few masks that we had to ration them down to 2 a day. And then luckily our staff started sewing, which was fantastic. But you'll see in that photo there, we ended up sending about 40 handmade masks down to Melbourne overnight. But this particular mother that did all the sewing did it for, you know, the big buffheads out there, not for the most of the staff. So she had to compromise for that day until we could get another shipment of new masks down to Melbourne. So again, I've mentioned communication a few times. It is really important with staff. So just about a week ago, we put out a staff survey asking a whole range of questions on this, because, you know, it was very stressful for us. And I'm happy to say the staff came back saying, yes, we did the right thing. And everything they did, everything we implemented was being followed by all staff. So we got 100% reply from that. Probably the best replies in our survey came about our communication. So Tanya, our CEO, was giving weekly email updates, especially in those early days when ScoMo was giving his press conferences. Tanya was busy jotting those down and typing them out straight away. So as soon as the press conference was over, all of our staff basically did a summary of what the Prime Minister was saying. And lots of emails, twice weekly emails of the New South Wales hotspots as well. So I'm still doing that. And I do that, I summarise that for our staff, because the New South Wales Government hotspot website is not the best to read. So I spend a bit of time summarising that for everyone. So look, overall, initially it was very, very stressful. A lot of sleepless nights, you know, 200 staff. We didn't know whether we would be shut down. That's a lot of people out of work. Also just trying to interpret the government advice, because really the government was lost as well in those early days. So COVID really caught us off guard, but it did prove to us that we can react very quickly in a crisis. And we now have really solid procedures for other potential disasters that may come along. And as I said earlier, we can all do risk assessments on the spot in our heads these days. So we did notice a massive decrease in flu this year as well, which was fantastic. And of course, we all learned how to wear a face mask. And I think that might be it for me. I went a little bit over time, sorry.
That's great. Thank
More
you.
slides than I remember.
Thank you very much, David, and thanks also to all the speakers for their presentation. So that was great. We've got a little bit of time for questions. So if anyone would like to ask a question, please send it through.
I've got that one from John Zavras there coming up. Yeah. I don't know if you can see it, but I can see it. I'll read it out. Regarding Envirolab, was the insurance cover overlooked since you deal with contaminated samples? So, insurance policies are very long and complicated. And this is probably a scenario. So this would have been covered in our industrial special risk insurance. And while I think we were, I forget now, John, the wording basically just had a little disclaimer for the insurance company, which we were very disappointed with. And as soon as they rejected that claim, we got our broker onto another agent, and we made sure we we talked about this particular case study, and if this ever happened again, would we be covered? And apparently we are, but we'll wait and see.
Very good. No, that's good. Thank you. A question for Jeffrey. Just generally on the risk assessment process, you know, you're trying to sort of work out the likelihood and the severity of the risk or the impact. How do you conduct a risk assessment when you have unknown risks or things that are fairly new? What's the sort of the thought process that you go through there?
Basically, Matt, we consider the operation size. We consider person experience. For very brand new, for example, a new PhD student come first year, if they try that type of thing, we'll normally consider high risk. But if their supervisor with 10 years, 15 years experience do, we are much more comfortable. So that type of thing, we are in the so-called risk-based, based on your experience, based on your knowledge, and based on the size of the volume. For example, you can try from small scale first, 1 milliliter flammable liquid, and different from half liter of liquid in the big reactor.
Yeah. Okay. So you're using all the information, all the experience you have to try and assess that
right.
risk.
We can't stop people trying new. It's a university research lab. There's a job to do that research and to explore. Yep.
Thanks, Jeffrey. A question for Kathy. Nigel spoke last time about using the hierarchy of controls to sort of mitigate risks. I think that's particularly relevant to schools, and you mentioned, you know, different people being able to use different concentrations of hydrogen peroxide. Obviously, the one obvious way of reducing risk is to stop the students doing experiments. How do you think you've got that balance right, and how many experiments do you think are not done now that used to be done because of those control measures?
I think a lot of it comes down to the teacher having to build a lot of trust with their students. So right from the beginning of the year, teachers have to build and basically gauge the dynamics in the room. But they would always, we call them material safety data sheets. They always, and our risk assessment tool is actually matched to those. So a teacher wouldn't, for example, get any chemicals out that are only allowed for year 12 with year 7. But in saying that, in selective schools, we do meet some highly gifted students who, and sometimes a year 7 student can actually be just as mature as a year 12 student. So in that case, the teacher may actually make a decision, well, you know what, with appropriate control and very close supervision in a small group, I'm going to allow this little group to do it. So, but we do, like Jeffrey said, we've got to let students learn, and they learn by doing. And in my experience, I've been I won't admit for how long I've been teaching, but I don't think the number of experiments have come down. I think teachers are probably conducting them in a safer way. We've got quite good relationship with tertiary academics. I think we seek support and advice, but I think science, thank goodness, is still hands-on, and I hope I'm never teaching in a lab where it's not. So, yeah.
Yeah, exactly. Yeah. That balance is very important.
Yeah.
Thanks, Kathy. A question for David. So you spoke about the case study. Obviously, you know, that's everyone's concern. It's the unknown or the occurrence that no one has predicted that you know can sometimes cause you some issues. How, I guess it's a question in general, but to you, David, in particular, how do you try and anticipate or avoid those unusual occurrences? You know, what did you learn from that particular experience that could inform future risks and prediction of events and how to sort of prevent them?
Yeah, exactly. And you're right. It's the unknown, and that's the world we live in. So, you know, a pharmaceutical lab might get, you know, known products coming in for testing, but as an environmental lab, we could just get absolutely anything coming in. So look, we do rely a lot on our customers telling us things and giving us a bit of warning, and we certainly have terms and conditions and warnings all over our paperwork for our customers. They must tell us these things. You know, it can not only be chemicals but biological as well. So I've done a little trial on some samples coming in eskies in melted ice water. and the E. coli was through the roof. It was almost like a broken sewerage sample in there. You know, and our staff are, you know, they've all got gloves on, but they're, you know, fishing their hands into this water. It's really bad. So yeah, look, we do try and educate our customers to let us know, but I always think we did have quite a good, firm induction procedure, but after this particular incident, it just strengthened that. And you know, just like unis, we get new people all the time, so they'll be either TAFE or university, and depending on how much lab testing they've done, they actually might not know a lot. So again, it's a lot of on-the-job training and just making sure our training is top-notch to cover any scenario. Yep,
that sounds good. So one final question, just one to each of the panelists. So we'd like to finish on a positive note. What's something positive that's come out of the COVID situation, and something that you think will take forward in some sort of beneficial way post where we are now? So Jeffrey, maybe you first.
I think that we can access lots of seminar, and it never happened before. For example, we can't access Western Australia colleagues, Melbourne, others without COVID, because it's all organized locally. Now on your fingertip, you can access around the world.
Yeah, so that connectivity has improved.
That's massive.
Yep, agreed. And Katherine, what about you?
Again, I think it's probably the communication. I think David's said how important communication is in any organisation. I think in schools it's improved. Teacher-student communication has improved as well. I think I don't think we're necessarily very good at posting or formalising what we wanted our students to do. Now it's all documented, and I think things don't slip through the cracks anymore.
Yeah, perfect. And David?
So I'm probably going to say that that I've learned from COVID that I could easily become a hermit and stay at home and not deal with anyone ever again.
A bit of self-reflection.
Never go to the shops again. I could happily do it.
Nice. Very good. No, that's right. All right, thank you guys. So tonight's been another event as part of the activities of the RACI New South Wales Industrial Chemistry Group. We hope you found this an interesting and informative topic. Our next event will be another in our series of site visits to showcase chemistry and science in industry. The next one will be a joint event with the RACI Early Career Chemists. Probably a virtual visit, but details will be forthcoming, so please stay tuned for the details of that event and future events, and contact me if you'd like to be added to our mailing list. The recording of this event will be uploaded to the RACI website. We've got a YouTube channel which is gathering all of the webinars that have been held, so please check that out. But please join me in extending a virtual thank you to our speakers tonight. To Jeffrey, Katherine and David, thank you very much for sharing your information with us, for your very informative presentation. And thank you everyone for listening. So good night and stay safe. Thank you very much.
Thank you.